Good day, everyone. So this will be our first topic for today. At yun nga, we will be talking about stoichiometry. So this is the last quarter for your second semester, and I hope na you will get something from this discussion. So yun nga, we will be talking about stoichiometry. So under stoichiometry, so the subtopics that we will be discussing are about first one, atomic numbers and mass number. Ano yung pagkakaiba ng atomic number and mass number? Sunod, it's all about the amounts of substances or the mole concept. So dito pag-uusapan natin ano yung mole, ano yung value ng mole, saan kinuha yung value ng mole. Another one is the molar mass and problem solving. I will try to explain to you ano ba yung paano i-solve yung molar mass ng elements and at the same time the molar masses of the compounds. And there are some problems here na gagawin ninyo. Another thing is about percent composition, just like the molar mass and molar mass. So there will be some problem solving here. And I hope ay masagutan nyo ng maayos. So, ano yung bumubuo dun sa isang compound? How many percent? So, that's percent composition. So, meron tayong dalawang cases na pag-uusapan. Another one is about chemical equations. Ito yung walang kamatayang balancing chemical equation. At the same time, I will add the different patterns of chemical reactions. So based from the chemical formula, you will be able to determine what kind of or what pattern of chemical reaction is that. Okay, so let us discuss first atomic numbers and mass number. As you can see here in this box is a symbol, X, A, and Z. So these letters represents something. So letter X represents the symbol of the element. Letter Z, on the other hand, represents the atomic number of the element, which is equal to the number of protons. And lastly, letter A represents the mass number of a certain element. Mass number is the combination of the number of protons and neutrons present in a certain element. So an example here is helium 2. So helium 2 has a symbol of He, then its atomic number is 2 and its atomic mass or mass number is 4. So meaning to say helium has 2 protons and 2 electrons. 2 protons and 2 neutrons rather. So that's it. So but if you're going to observe the periodic table, you may observe that there are certain elements wherein, not certain elements pala, but all of the elements have mayroong decimal yung kanilang mga mass number. So why is that? Kasi yun ay mga relative atomic masses. Yun sa relative atomic masses, kinuha yung sinolve yung kanilang amount, then yung atomic mass ng bawat element na yon. So it is due to the presence of isotopes. Ano ba yung isotopes? So when you say isotopes, there are varying number of neutrons. So when we are talking about atomic number, mass number rather, so we use the unit AMU. So what do you mean by AMU? When you say AMU, it is atomic mass unit. Again, it is the unit used for mass number. So where is AMU derived? AMU is derived from carbon 12. Actually, gumamit ng iba't ibang elements for as reference for AMU, pero they find out na ang pinaka-appropriate gamitin for AMU is, our reference for AMU is carbon 12. Why? Because carbon 12 or the isotope of carbon 12 is has exactly 12.00 na mass. AMU. Ano po? So, 12.00. Ibig sabihin, a certain 1 AMU is equals to 1 over 12 of the mass of carbon 12. Again, 1 over 12 of the mass of carbon 12. That's equal to 1 AMU. So, AMU is derived from the mass of carbon 12. This isotope of carbon was used because it has an exact value of 12.00 unlike other elements. So, sabi ko nga kanina, 1 AMU is equals to 1 over 12 of the mass of carbon 12. So, that's AMU. So, we will be using that unit. So, yung sinasabi ko kanina, why are there elements having the same atomic number but varying atomic masses? So, it is due to the presence of isotopes. So, when we say isotopes, these are elements having the same atomic number but different atomic masses. So, iba-iba yung kanilang atomic masses. And why is that possible? That is due to their difference of their neutrons in their nucleus. So, dito tingnan natin the formula in looking for the neutrons is equal to the atomic mass minus the atomic number. So that's atomic mass minus atomic number. And here in the example are the different isotopes of carbon. We have carbon 12, carbon 13, and carbon 14. So as you can see, their atomic number are all the same, but their atomic mass are different from one another. So with 12, 13, and 14. So by subtracting the atomic number from the atomic mass, we will arrive at 6, 7, and 8. And those numbers or those values represents the number of neutrons in each isotope of carbon. So carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and on the other hand, carbon 14 has 8 neutrons. So that's isotope. So yung ibang elements, iba-iba din yung, meron din kanya-kanyang isotope yun. So depending on their abundance, so sinosolve yung kanilang relative atomic masses. At kagaya nga sa carbon, ang relative atomic mass ng carbon is 12.01. So, yun. Kasi dinagdag pa yung mass ni carbon 13 at saka ni carbon 14 na ito lang yung kanilang value, around 1.1% lang si carbon 13 and 0.0001% lamang si carbon 14. So most abundant ay si carbon 12. Okay. So, these atoms, molecules, and different particles na napakaliit or very difficult to count. No, aminin naman natin o hindi, it is very difficult to count. Even the most powerful microscope can do a little help only. So by that, meron tayong kailangang gamitin, and there is a need to represent these very small particles. And what are these particles? So yun ay tinatawag nating mole. So that's where the mole comes to action. So dito, gagamitin natin yung salitang mole. Hindi taling, hindi yung naghuhukay sa lupa, but the mole which is used in chemistry. Anyways, this mole concept is already introduced to you when you were in grade 9. And this will be just a recap on what we have discussed last time nung kayo grade 9 pa. So, what do you mean by mole? Mole is the amount of substances that contains as many atoms, molecules, ions, and other nanoscale units as there are atoms in exactly 12 grams of carbon 12. Ayan, ginamit na naman si carbon 12. So, inuulit ko po, ito po gaano kadami yung atoms or molecules and ions o yung iba pang maliliit na units as there are atoms in exactly 12 grams of carbon 12. Okay, so Next, what is the value of moles? The value of moles is called the Avogadro's number. So it is equal to 6.02 times 10 raised to the 23rd particles. So whether it is atoms, molecules, or ions, or other smaller particles. So that's the value. 1 mole is always equal to 6.02 times 10 raised to the 23rd particles. We will be using that value in our conversions, specifically in our stoichiometric conversions, which will be discussed pa sa mga banda-banda dyan. Okay, so by the way, it is called Avogadro's number nga pala because in honor to Amedeo Avogadro, the one who he is not actually the one who discovered this value, but his study led to the discovery of this value. Kaya pinangalan sa kanya yung number na yan, Avogadro's number. So, to serve as a mediator, kanina pinag-usapan natin si mass number at saka si moles. Or si mass at saka si moles. Ngayon, ang problema, paano natin pag-connectin yung dalawa? Kasi, as you can see, si mass, macro scale yung kanyang cover. Si moles naman, nanoscale. So, medyo malayo yung kanilang pagitan. So, to serve as a mediator, there must be a unit that will connect the mass with moles. And that is called the molar mass. So, ano po ba yung molar mass na sinasabi natin? Molar mass is the mass in grams of 1 mole of the substance. Again, the mass in grams of 1 mole of the substance. Gaano kabigat yung isang mole ng isang substance. Halimbawa, so again, when I say 1 mole, that is equal to 6.02 times 10 raised to the 23rd. So for example, if we are talking about carbon 12, 1 mole of carbon 12 is equals to 6.02 times 10 raised to the 23rd atoms of carbon. So 1 mole of that, the molar mass of that certain amount of carbon is equals to 12.01 grams. Okay, or that's 12.01 gram per mole because gram per mole is the unit for molar mass. Okay, so yan. So kung ating pagsasama-samahin yung 6.02 times 10 raised to the 23rd unit of atoms ng carbon 12, that will be equal to 12.01 grams. Or simply, kapag elements lang ang pinag-uusapan natin, we just look at the periodic table. Kasi their atomic masses is equal to their molar mass. Ano? So, 1 mole of those elements, or kung ano mang element yan, 1 mole of nitrogen. So, 1 mole of nitrogen is equal to 14.01 gram per mole, which is also equivalent to its atomic mass na 14.01 AMU. So, madali lang kapag ka-elements yung ating pinag-uusapan. So, any element here in the periodic table, you just simply look at their relative atomic masses, and from there, you will get its molar mass. Okay, so getting the molar mass of elements is very easy, but how about the molar mass of a compound? So the molar mass of a compound is equal to the sum of the mass of the elements composing the compound in 1 mole. So for example, meron tayong water. So water, to get the molar mass of water, we need to determine the atoms composing water. So the atoms composing water are 2 hydrogen and 1 oxygen. So that's H2O. Again, 2 hydrogen atoms and 1 oxygen atom. So we have to compute separately muna yung molar mass ng bawat element. So H, or hydrogen, we have 2 atoms multiplied by its molar mass, which is 1.01 gram per mole. So 2 times 1.01 gram per mole is equals to 2.02 gram per mole. Oxygen, on the other hand, is 1 times 16 gram per mole is equals to 16. So we add those two molar masses to have the molar mass of the compound water, which is equals to 18.02 grams per mole. So that's the molar mass of water. Another example here, the molar mass of C4H6O2, an organic compound. If I'm not mistaken, this is a sugar. Okay, so again, kagaya ng ginawa natin um, kagaya ng ginawa natin kanina doon sa water. So determine natin ilang atoms ang bumubuo sa bawat elements. So sa carbon, meron tayong 4, sa hydrogen, meron tayong 6, and sa oxygen, meron tayong 2. Then, we multiply those values by its atomic mass. Then, independently, meron na tayong iba't ibang molar masses. So, we have 48 for carbon, 6 for hydrogen, and 32 for oxygen. So, those molar masses ng bawat elements, i-add natin. So, we get the sum, then we will arrive at 86 gram per mole, which is the molar mass of this compound. Another example, we have ammonium phosphate. Ammonium phosphate, again, determine the number of elements present in the compound. So we have 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen multiplied by its atomic masses or its molar masses. Then we will arrive at these answers: 42.03 gram per mole, 12.096 gram per mole, 30.97 gram per mole, and 64 gram per mole. We add those molar masses at ang magiging sagot natin is 149.096 gram per mole. So now it's your turn. You try to solve for this. Solve for the molar mass of the following elements or compounds. So, i-pause nyo muna yung video, then sagutan ninyo ito. And after answering this, pwede na ulit i-play. The answer for the following are, first, iron 55.85 gram per mole based on the periodic table. Bromine gas because it's Br2. So, that's 159.80 gram per mole. Silver, 107.87 gram per mole. Iron, 159.70 gram per mole. That's iron 3 oxide. Next, we have magnesium hydroxide, 33 gram per mole. Calcium carbonate, 100.09 gram per mole. Iodine monofluoride, 145.90 gram per mole. And xenon tetrafluoride, we have 207.29 gram per mole. I hope you get those answers correctly. And I hope you really learned how to solve for the molar masses of those elements and compounds. Next, the composition of a certain substance can be expressed by the sum or by the number of atoms of each type per molecule or by the mass of each element in a mole of a compound. So, pwede nating malaman ano yung bumubuo dun sa isang compound by simply having this one. So, this is called percent composition. So, percent composition is the term used to describe the percent by mass of each element in a compound. It is typically found using the molar mass values for both the elements in the compound and the compound itself. Meron tayong dalawang way paano masosolve si percent composition or dalawang situation. Una, kapag ang given natin ay molar mass or kapag ang given lamang ay si chemical formula. So, kapag chemical formula lang ang given natin, we solve for the molar mass of the element. Then, we solve for the total molar mass of the compound. So, then molar mass of the element over the molar mass of compound times 100 will be the molar mass of each element. Then, another one is if the relative mass of the compound and the elements are given. So I will give you an example. First one. First, meron tayo ditong water. Water na we have to find the percent composition of water based on its chemical formula, H2O. So, gaya ng ginawa natin kanina sa molar mass, we solve for the individual molar masses of hydrogen and oxygen. So, for hydrogen, that's 2.02 gram per mole. For oxygen, 16 gram per mole. So, we will arrive at a total na 18.02 gram per mole. So, following the formula, percent composition of element X is equals to the molar mass of the element X over the molar mass of the compound times 100%. For hydrogen, 2.02 times 2.02 gram per mole over 18.02 gram per mole times 100 is equals to 11.21 gram per mole. For oxygen, we have 16 gram per mole over 18.02 gram per mole times 100% is equal to 88.79% of oxygen. So, yan po yung ating ang sagot sa percent composition ng hydrogen and oxygen. And if you're going to add our answers, ang ating pong sagot ay 100%. Yan ay kapag ang given natin ay chemical formula. However, if our given are the masses of each compound or each element, so ang kailangan lang natin gawin is i-substitute na lamang yung mga given doon sa ating formula. Just like here, a certain organic compound wherein hydrogen weighs 2.5 grams and carbon weighs 7.5 gram. So ang total mass daw ng ating sample is 10 grams. So having those given, so 2.5 gram of hydrogen over 10 gram of the compound times 100% is equals to 25%. Next one, for carbon, that's 7.5 over 10 times 100% is 75%. Again, kapag pinagsama ninyo, that's equal to 100%. So that is the percent composition. So again, you try this following problems. So try to solve for the percent composition of the non-metals in the following compounds. So yung non-metals na lamang yung hanapin ninyo. For number 1, you try to look for the percent composition of oxygen. Number 2, oxygen and hydrogen. Number 3, carbon and oxygen. Number 4, bromine. And number 5, fluorine. So pause the video. Then after answering all the items, then you may play it again for the answers. Okay, so number 1, the answer for number 1, iron 3 oxide. So that's 30.06% oxygen. For magnesium hydroxide, that's 54.86% oxygen and 3.46% hydrogen. Next, calcium carbonate. Ang atin ay carbon at saka oxygen, 12% carbon and 47.96% oxygen. Another one, the bromine from magnesium bromide. We have 86.80% bromine, and for our aluminum fluoride, meron tayong 67.87% fluorine. So yun po yung sagot, and I hope you arrive at correct answer. Next one, we have the chemical equations. So sabi ko kanina, chemical equations, we will be dealing with balancing chemical equations and at the same time the different patterns of chemical reaction. So a balanced chemical equation indicates the relative amounts of reactants and products required so that the number of atoms of each element is in the reactant equals the number of atoms of the same element in the products. So kailangan magkaparehas yung number of atoms doon sa reactant side at doon sa product side. So this is our chemical equation. So again, our chemical equation is composed of two sides. The first part on the left side is called the reactant side. Ito yung mga compounds or elements na involved sa chemical reaction. Then after the chemical reaction, on the right side, we have the product side, wherein ito naman yung mga nabuo after the chemical reaction. An example here is the hydrolysis of water to form hydrogen gas and oxygen gas. So H2O or H2O produces H2 and O2. So kung titingnan po natin, medyo sablay ito ating chemical equation kasi this breaks the rule or breaks the law of conservation of mass. Ano sinasabi sa law of conservation of mass? Um, Sabi sa law of conservation of mass, matter can neither be created nor destroyed. Ibig sabihin, kung ano yung ginamit mo, dapat yun din yung lalabas sa iyo. So, dito meron tayong sa reactant side, meron tayong dalawang hydrogen at isang oxygen. Pero patak natin ng product side, meron tayong dalawang hydrogen at dalawang oxygen. So, saan ang galing yung ating ipang oxygen? So, ito po yung problema sa mga chemical equation na unbalanced. So, mali siya doon sa ating law of conservation of mass. So, kailangan natin siyang i-balance by putting coefficients in the first part of our components. So, ilalagay natin sa harapan ng bawat component. So, example natin, itong ating given na chemical formula, H2O produces H2 and O2. So, ilagay natin sa table para makita ninyo ano yung pagkakaiba nilang dalawa. So, we have the column for element, column for reactant, products, and is it balanced or not? So, for hydrogen, kita natin na parehas lamang yung number ng hydrogen. We have 2 in the reactant and product side. On the other hand, for oxygen, we only have 1 oxygen in the reactant side, but we have 2 oxygen in the product side. So, hindi siya equal. First step, kailangan nating maglagay ng coefficient wherein si oxygen in the product and reactant side will be equal. So, we are going to put the coefficient 2 doon sa reactant side para maging dalawa din yung ating oxygen. So, kung titingnan natin, naging equal na po si oxygen, pero ang problema na apektuhan sa hydrogen. Kasi, hindi naman pwedeng ilagay natin doon sa oxygen, sapat ng oxygen yung coefficient. Dapat doon sa mismong simula or sa mismong harap ng compound. So, anong nangyari? Naging 4 si hydrogen, pero balance na si oxygen. So, the next step to do is to put another coefficient doon naman sa harap ng H2 doon sa product side. So, if we do that, the number of atoms for hydrogen and oxygen from the reactant side and the product side will be equal or will be balanced. So our final equation in this chemical equation is 2H2O produces 2H2 plus O2, or simply 2 molecules of water produces 2 molecules of hydrogen gas and 1 molecule of oxygen gas. So that's it. Another example here, we have N2 plus O2 produces N2O5, or nitrogen gas added to oxygen gas produces dinitrogen pentoxide. So, para makuha natin yan, so again, ilagay natin sa table. And as you can see here, balance si nitrogen pero hindi balance si oxygen. So, ang kailangan natin gawin, kailangan natin mabalance si oxygen. Kasi okay na yung nitrogen. So, we have 2 for reactant side, we have 5 for product side. So, that's 2 and 5. So, in order to make them balance, kailangan nating lagyan both side ng coefficient para silang dalawa ay mapagtagpo natin doon sa value na 10. So, O2, para maging 10 yung O2, we put 5 in front of O2, then we put 2 naman dun sa N2O5 para maging 10 din sa oxygen. So, in this situation, na-equal na natin si oxygen. Ang problema lang ay mas madami na ngayon yung nitrogen sa product side as compared to the reactant side. So, ang gagawin natin, we need to add another coefficient in front of N2. Okay, so for this one, ang gagawin natin, we need to put 2 in N2 so that nitrogen in the reactant side will be number 4, wherein the product side naman already 4 na siya. So, after the long run, so nitrogen is the nitrogen in reactant in product side will be 4, and the oxygen in the reactant and the product side will be 10. So, kung titignan natin, balance na po yung ating chemical equation. So, our final equation is 2N2 plus 5O2 produces 2N2O5, or 2 molecules of nitrogen gas added to 5 molecules of oxygen gas produces 2 molecules of dinitrogen pentoxide. So, that's our final chemical equation. So, for this one, you try to balance the chemical equation. And, again, pause nyo muna yung video habang nagsasagot kayo. Then, later on, I will reveal the answers. Okay. So, for number 1, ang atin pong sagot is, we put the coefficient 2 in front of O2 and 2 in H2O. So, yun po yung ating chemical equation. Then, for number 2, 3 for H2O and 6 sa HF. Number 3, 2 sa AgNO, 2 sa Ag. Number 4, we have the coefficients 4, 3, and 2 consecutively in each of the following components. Then, number 5, 2 NaCl and 2 Na. Now, all our chemical equations are balanced. So, the last topic that we will be discussing is all about the patterns of chemical reaction. So, when you say patterns of chemical reaction, bawat chemical reaction kasi mayroong kanya-kanyang kind or mayroong kanya-kanyang type. Depende kung ano yung kanyang general chemical formula. So, mayroong chemical reaction na nagsasama, naghiwalay, ipinagpapalit yung isa sa isa, mayroong nagpapalitan, at mayroon din mang sa pagsusunog. So, the first pattern of chemical reaction is called the combination reaction, having the general equation A plus B produces AB. So, pwede nating ihalin tulad ito doon sa couple wherein si girl and boy after a certain period of time nagligawan, then naging AB or naging couple sila. Next one, decomposition reaction. Ito naman po yung kind of chemical reaction wherein a larger molecule splits into smaller particles. Kagaya ng AB produces A plus B. So, ito naman nag-break. Next one, displacement reaction. AB plus C produces AC plus B. So, one component replaced the another to form a new compound. So, kung titingnan natin, pwede natin ikumpara ito doon sa mga may third wheel. Third party. Yan. Next, exchange reaction. AB plus CD produces AD plus BC. Dito naman, nagpalit ng partner. So, each of the following elements, a compound, exchanged its partner. Then, combustion reaction. This is the general chemical formula. Ang medyo maiiba lang dyan is yung pinakasimula, CHN. CHN represents the organic compound. So, any combustible organic compound ito, na it will always react with oxygen gas to produce carbon dioxide and water. So, yan yung ating patterns ng chemical reaction. So, based on these chemical reactions, try natin sagutan itong pinakauling exercises. Determine the pattern of chemical reaction. So these are the chemical formula na ginamit natin doon sa balancing chemical equation. So now, let us try to determine the pattern of chemical reaction. So again, you pause the video, then after answering, you may play it again. So for number 1, it is combustion reaction. Kung makikita po natin, that's CH4 plus 2O2 produces CO2 plus 2H2O. So that's combustion reaction. This one, we have exchange reaction. Nagpalit ng partner. Another one, we have displacement or single displacement. Merong isang pinalitan. The number 4, we have synthesis reaction. Merong dalawang maliit na particles na nagsama to form a larger compound. So that's synthesis. Kabaligtaran ng number 4, si number 5, which is decomposition, isang malaking molecule na naghiwalay. And for number 6, we have, again, synthesis just like number 4. Two smaller components combine to form a larger component. So that's it for number 6. So I hope you really learned something about this video, and I'll be sending to you yung inyong formative assessment siguro by tomorrow or the day after tomorrow. Then yung mga teachers niyo na yung bahalang mag-check, or sa kanila niyo na lang i-send po. So thank you very much. I hope you learned something, and that will be for the day. Goodbye.